I was working this problem about a physics problem with a student about Young's modulus and stress and strain, and we entered the answer into a system and it came out wrong, and I said, well, maybe it wants it in a different format, I don't know. But then as I was driving to my next appointment, I realized, or to 2 appointments later, because my next appointment was at the same place, I was at a library, I realized that I had made a mistake. I told the student that to convert from meters to millimeters, divide by 1,000. Well, no, meters times 1,000 millimeters per meter. So see, the meters cancel out, and then you're left with millimeters. So to convert from meters to millimeters, you multiply by 1,000. Then this question, then you get the right answer for this question. So Young's modulus equals stress, and here's stress right here, so I don't have to break that one down, but divide it by strain. And strain can be written as L0 divided by, or I'm sorry, got that backwards, delta L, the change in length, divided by the initial length. And a lot of times the modulus is given in pascals, which is newtons per square meters. Stress is force divided by area, which is a lot of times newtons per square meters, which is pascals. So in other words, make sure that you express, when you're using pascals, express your lengths in meters. And then whatever the question asks you to convert to, if it wants it in millimeters, you multiply, not divide, by 1,000. If it wants it in centimeters, you multiply by 100. So in this case, it says Young's modulus. Well, let me manipulate this, and then I can get a formula to find the change in length, because that's what it's looking for, the compression. So if I take this fraction out of the denominator, I multiply by the reciprocal, L0 divided by delta L. Dividing by a fraction is multiplying by the reciprocal. Then I can multiply both sides by delta L and divide both sides by y, and I get delta L, the compression, equals stress times the initial length divided by Young's modulus. And in this case, the stress is 1.51 times 10 to the 8th pascals. And now somehow I have to make more room, so I'm going to have to do this. I need a little bit more than that. Hold on. I'm making more room. I'm going to move this over a little bit. 1.51 times 10 to the 8th pascals times 0.48 meters. And I'm putting in the units so I make sure I get the right units to end with, divided by 1.8 times 10 to the 10th pascals. And you can write this formula down on a cheat sheet wherever you have your notes. The change in length equals the stress times the initial length divided by Young's modulus. And now this is in meters. See, the pascals cancel. What's left is meters. If I multiply it by 1,000, see, I purposely made that mistake to see if someone would catch it. Well, I'm lying about that. I just made a mistake. I said divide by 1,000. You have to multiply by 1,000. So 1.51 times 10 to the 8th pascals times 0.48 meters divided by 1.8 times 10 to the 10th pascals is going to give the compression that it can withstand in meters. Multiply that by 1,000 to get millimeters, and that comes out to, hold on, I had Desmos open here, 0.48 times 1.51 times 10 to the 8th divided by 1.8 times 10 to the 10th times 1,000, 4.02, 6666667, 66 forever. Depending on what the question or where you're entering it, how it wants you to enter it, it could say round to the nearest whole number, round to the nearest tenth, but this is the exact answer. This is the approximate answer, 4 point, I'm just going to round it to 2 decimals, 4.03 millimeters. Okay, so don't make the mistake that I did, that I made purposely, just to test you. I was testing you. Meters times 1,000 is millimeters. Meters times 100 is centimeters. It's not meters divided by 100 or divided by 1,000. Meters times 1,000 is millimeters. So this answer to this one is 4.03 millimeters.